of refractive index of any medium, and you also know about the absolute refractive index of any medium. Now we move to the next section, that is about the relation between refractive index of a medium and speed of light. In the last part, in the laws of refraction, you got to know that the refractive index of the second medium, suppose this is the second medium, this is the first medium. So the refractive index of the second medium with respect to the first medium, it was defined as the ratio of sine of angle of incidence in the first medium to the sine of angle of refraction in the second medium. But suppose that we do not have the idea of the value of I or the value of R. We do not know the value of angle I or angle R. Then what do we do to find the refractive index of the second medium with respect to first? It's very simple. We define the refractive index of the second medium with respect to first as the ratio of speed of light in the first medium to the speed of light in the second medium. Now this is the second ratio, that defines the refractive index of the second medium with respect to first. Suppose we will have a simple example for it. We have to find the refractive index of glass with respect to, suppose here, if I do not mention here that the first medium is air, suppose I rub it. It is not mentioned here that the first medium is air. Then also you will assume that the first medium here is air, and it will be the absolute refractive index of glass. So for this, what do we do? Here the first medium is air, obviously. Suppose it is the first medium is air and the second medium is glass. Then what do we do? According to this definition, we have the ratio V1 by V2, that is speed of light in the first medium, that is in air. And you know about it. The speed of light in air, it is denoted by c, which has the value of 3 into 10 to the power 8 meter per second. And what about the speed of light in the second medium? The second medium here is glass. So the value of c is 3 into 10 to the power 8 meter per second. And the speed of light in glass, it is approximately 2 into 10 to the power 8 meter per second. So we get the value of refractive index of glass with respect to air. So the refractive index of glass with respect to air, that is the absolute refractive index of glass, it will be 3 by 2, that is 1.5. And as you can see here, both of them, they are, the numerator and the denominator, they are speed of light. So they have the same units, and so the refractive index, it has no dimensions, it has no units, the refractive index. So we got the refractive index of glass, that is the absolute refractive index of glass. Similarly, if you are asked that you have to find the absolute refractive index of water, then what do you do? Here the value of c, it will be similar, and in the place of Vg, you will have to put the value of speed of light in water. It's very simple. Now, in the next section, we have the idea of this ratio. Now, what can we do? Suppose that if we do not have the idea of angles, the angle of incidence or the angle of refraction, and we do not have the idea of the speed of light in the first medium and the speed of light in the second medium, then what do we do? Starting from this very first part, V1 by V2. What can we do here? In mathematics, we use the technique that the same quantity, the same number, it can be multiplied in the numerator and the denominator, and the ratio will remain unchanged. So we multiply it, the numerator also and the denominator also, we multiply both of them with c. We have the motive of finding refractive index of second medium with respect to first. So we can write over here c by v2. It is taken apart, c by v2, and one more c is left here. So we can write here v1 by c. One more thing, here the refractive index of glass or refractive index of water or refractive index of diamond of any medium, what can we write over here? Refractive index of any medium. In general, refractive index of any medium, what will it be? It will be in the place of glass, it can be water, it can be diamond, it can be anything. So this C, it will always be there because in absolute refractive index, the first medium is always air. So refractive index of any medium, I am not mentioning here air, so you must know that here the first medium is air. That is, we are talking about the absolute refractive index of the given medium. What will it be? C by V. V, that is the speed of light in the given medium. The given medium, it might be glass, it might be water, it might be diamond, anything. So it will be defined as the ratio of speed of light in air, that is in the first medium, to the speed of light in the given medium, that is the second medium. C by V2, compare this part. C by V2, that is C by V2, 2 here, it is the medium. It might be anything, it might be glass, water, anything. And 1, these are the names of the mediums. 2 is the medium, second medium, 1 is the first medium. So C by V2, C by V2, the what will it be? C by V2, it can be written as mu2, that is the absolute refractive index of the second medium. It might be anything, any medium. But in this part, we can see that V1 by C, what can we do here? V1 by C, it can be written as, if C by V1, it will be written as mu1. I'll write it here. If C by V1, it can be written as mu1. It's very simple. Comparing from this part, C by V1, 1 here is the name of the medium. It can be anything. It can be water, glass, anything. So mu1 here, it is defined as C by V1. But we do not have this part. We have the reciprocal of this part. C by V1 will be mu1. So V1 by C, it can be written as 1 by mu1. I think it must be very clear to you. Now what do we conclude here? Mu21, we had to find mu21, and the outcome here is, what is mu21? It can also be defined as mu2 by mu1. So this is the third ratio that we have for defining the refractive index of second medium with respect to first. We'll have a simple example for it. And one more thing, here the medium is not mentioned. The medium is not mentioned. What does it mean? That the medium, the first medium here is air. Here also the first medium is air. We'll have a simple example for it. Suppose you have to find the refractive index of glass with respect to water. Then we have three options. If we have the idea of angle I, angle R, we can find the refractive index of glass with respect to water with the help of this ratio. If we do not have the idea of angles, we can use this ratio, that is speed of light in first medium, that is in water, to the speed of light in second medium, that is in glass. Suppose we do not have the idea of speed also, what can we do? We can use this ratio, that is the absolute refractive index of second medium. Here the second medium is glass. So the absolute refractive index of glass to the absolute refractive index of the first medium. That is, the first medium here is water. So the absolute refractive index of water. I think with the help of these things, the concept of relation between the refractive index of any medium and the speed of light, it must be very clear to you. Now we will be talking about the conditions for which the light ray will not deviate from its path. One of the conditions is already known to you. This is the surface of separation. Suppose this is air, this is glass. The first medium is air and the second medium is glass. And the light ray, it is traveling from air to glass. The first medium is air and the second medium is glass. But there is no deviation in the path of light ray. The light ray does not deviate from its original path. This was its original path, and after it passes from one medium to another, that is from air to glass, then also the path of the light ray is not changing. What was the condition? When the incident ray was normal to the surface of separation. This is the first condition. Incident ray is normal to the surface of separation. This is already known to you. So this was our first condition for which the light ray will not deviate at all from its original path. And for it, the angle I will be 0. That is, angle of incidence will be 0 because the incident ray and the normal, they overlap each other. So the angle between them is 0. Angle of incidence is 0. Now, what about the second condition? Suppose the refractive index of both the mediums is same. This is our first medium and this is the second medium. It might be anything, any medium. So for this case, if the refractive index of the first medium is equals to refractive index of the second medium, then also there will be no deviation in the path of the light ray. I wrote it over here, mu1. It must be very clear to you. No medium is mentioned here. It means that refractive index here is the absolute refractive index. So the absolute refractive index of first medium, if it is equals to absolute refractive index of the second medium, then also there will be no deviation in the path of light ray. Now, if refraction takes place, if light ray travels from one optical medium to another, then what will be the effect on the speed of light, the wavelength of light, and the frequency of light? Now, firstly, we should know about the frequency of light. If the source is not changed, suppose here we have the bulb or the tube light, that is the source of light. So if we are not changing the source, then the frequency of light will not change. Suppose this light, it is traveling from air, and this light only, it passes to water or it enters in the other medium, in the next medium, that is water, glass or anything, then the speed will decrease or the speed will increase. The wavelength will also change, but the frequency will remain the same until the source of light is not changed. If you replace the bulb or you replace the tube light with some other source, then the frequency of light will change. The frequency of the light that is coming from that bulb is different from the frequency of light that is coming from this tube light. But if the source is same, the frequency of light won't change. But these two things, the wavelength and the speed of light, they will change if they enter from one optical medium to another. Now, we'll look for it that how is the change here taking place. As you know, when light ray, it enters from a rarer medium to a denser medium, then suppose here we have the rarer medium, that is air, and the denser medium, that is glass or water, anything. You know about it that whenever a light ray, it passes from a rarer medium to a denser medium, then its speed decreases and so it shifts towards the normal. This would have been the original path of the light ray. I have produced it here, but it is not the condition here. It shifts towards the normal because the light ray travels from optically rarer medium to optically denser medium. So the speed of light decreases here. If we reverse the case, if the light ray has to travel from glass to air, that is from a denser medium to a rarer medium, then the speed of light will increase. So there will be change in the speed of light. I'll mention it here. If light travels from optically rarer to denser medium, then the speed decreases and vice versa. If the condition is reversed, if the light ray is traveling from denser to rarer medium, obviously its speed will increase. What about the wavelength, the frequency will remain the same. I told you, until the source of light is not changed, the frequency will not change. It will remain the same. The frequency in air, it was suppose the frequency in air was smaller. Then when the light ray, it passes to glass or it passes to water, to any second medium, then also the frequency will remain the same. The frequency won't change. Now we will talk about the wavelength of light. For it, we must have the knowledge of this expression. You must have learnt about it in your class 9th when you got to learn about wave motion. This expression, it's very simple. It is the relation between the speed of any wave and the frequency of that wave and the wavelength of that wave. So it is the relation between V, F and lambda. Suppose the speed of light in air, you know about it, it is c, it is denoted by c, that is equals to 3 into 10 to the power 8 meter per second. When this light ray, it enters in the second medium, suppose this is any medium, we have taken the example of glass, this medium, it can be anything. Now suppose the speed of light in this medium is v, speed of light in this medium. This medium, it can be anything. Now, if the light ray, it is traveling from air to any medium in the second medium, then for this condition, the F will remain the same. Air and the medium. Here, air is the first medium and this medium, it might be anything, glass, water, anything. So the frequency for both of them will be same because the source of light is not changed. But what about the speed? The speed in air, it was c, but the speed in the given medium, suppose it is v. And the wavelength of light, I must tell you that it might be possible that the color of light is known to you. It might be violet, it might be red, indigo, blue, green, anything. So as long as all these colors of light, they are traveling in air, then their wavelength remains the same. But as soon as these light rays, they enter in any optical medium, water, glass, diamond, anything, their wavelength changes. All of the components of white light, they have different wavelengths. We'll talk about it in the next part when we talk about the spectrum. Now, suppose that the wavelength of light in air, it is lambda, and the wavelength of light in the given medium, that is in the second medium, is lambda dash. We have the motive here to find the relation between this lambda and lambda dash. What can we do? F, as you can see here, if we want to find the value of f, make f the subject, it will be v by lambda. So from here, this f, it is equals to v by lambda, that is f will be equals to c by lambda. The speed here is in air is c. Now in this part, f, it is equals to, again the same part, v by lambda. So here the speed of light in the given medium is v, and the wavelength of light in the given medium, it is, we have assumed it to be lambda dash. C by lambda, it will be equals to, suppose this is our equation 1, this is our equation 2. So C by lambda is equals to V by lambda dash. And as we have to find the value of lambda dash, because the value of lambda, it will be known to us, the wavelength of light in air, that is in the first medium, it will be known to us, and we might be asked to find the wavelength of light in the given medium. The given medium, it might be glass, water, anything. So we will make lambda dash the subject. The c will come over here, v by c, and the lambda will come here. So what do we do here? V by c. As you can see here, in the last part I told you that c by v, that is speed of light in air or in vacuum to the speed of light in the given medium. It will be equals to what? Refractive index of the given medium. That is the absolute refractive index. If the first medium is not mentioned here, it means that the medium is air. So C by V, that is C by V medium, it is equals to the absolute refractive index of the given medium. But here we have V by C. What does it mean? We can write this V by C. If it is C by V, it was mu medium, absolute refractive index of the medium. So it is the reciprocal of this part. So we can write it over here 1 by mu. 1 by mu, medium, that is any medium, multiplied by lambda. So what do we conclude here? This lambda dash, that is the wavelength of light in any given medium. Suppose we take an example here. If the medium is given to us, if the medium is glass, and we are asked to find the wavelength of light in glass. When the light ray enters from air to glass, and we are asked to find the wavelength of light in the given medium in glass, what do? It is equals to lambda by mu medium, that is wavelength of light in which medium? In air. The wavelength of the lambda here is what is it? What it is? It is the wavelength of light in the first medium, that is in air, by mu medium, that is the absolute refractive index of the given medium, that is here the glass. So if we have the knowledge of lambda, that is the wavelength of light in air, and the refractive index of the second medium of the glass of the given medium, then we can find the lambda dash. So it was all about the relation between lambda dash and refractive index of the given medium.